Hello, and thanks for joining us today. My name is Anthony Avalos. I'm a Windows Partner Development Specialist on the AWS EMEA Windows Partner team. Today, we are here to share with you insights on how to optimize when migrating Microsoft workloads to AWS. After I provide some introductory insights, I will hand it over to Sergio Santos from Crayon, one of our trusted AWS Microsoft Competency Partners. To get started, I will provide some insights on our experiences from helping a significant amount of customers successfully migrate to the cloud. There are many drivers for customers to initiate the journey to the cloud. Customers are driven by compelling events such as cost objective, target dates to exit data centers, or end-of-life hardware and software. But recently, the conversation is changing. Companies expect more than just cost savings and efficiency, even though customers are achieving 25 to 50% savings in AWS versus on-premises cost. They want to be able to move faster as businesses and transform customer experiences. They want to deliver digital transformations and modernize. They want to reinvest cost savings to drive new innovations and business models. As the cloud becomes mainstream, it is no longer a question of if, but when customers will migrate to the cloud. But enterprise migrations can be challenging. It is a disruptive process for your business and IT organization specifically. You must deal with some complex challenges, including deconstructing and understanding the on-premises technical environment while changing your operational processes while you're helping your organization through cultural change, among other things. A significant majority of businesses are running Windows workloads today. When adding Windows to migrations, it creates even more challenges. You need to discover the on-premises license footprint and actual usage, and understand complicated licensing rules when you're moving over to the cloud, and also weigh options and optimize your cloud environment to reduce licensing burdens. We have received advice and best practices from thousands of customers that we have helped successfully migrate to the cloud, and they have told us that it's key that leadership takes a key role in pushing a migration forward. They have to demonstrate not just sponsorship, but convicted leadership, and set, measure, and assign responsibility that have clear business outcomes. On top of that, you must develop cloud skills within your organization, such as the Cloud Center of Excellence, and also getting your workers trained and certified on AWS. When enterprises are migrating to cloud, efficient planning of Windows workloads will be critical to successful migrations. This also presents an opportunity for improvements in cost, performance, and agility in the enterprise. First, let's look at some key figures that highlight the importance of having a defined Windows strategy when migrating. According to IDC, 70% of enterprise-based applications are Windows-based, and 82% of Windows applications are still on-premises. And according to Microsoft, 91% of enterprise customers have Windows Server and SQL Server licensing. With 50% of enterprises planning to migrate to cloud within the next 24 months, choosing a cloud platform that will help you to increase performance and innovate faster is an important decision for business leaders to make. AWS has run Windows for over 11 years. And according to a report by IDC, we host nearly 2 times as many Windows Server instances in the cloud as Microsoft. At AWS, we like to say there is no compression algorithm for experience. And that's because you can't learn certain lessons until you get to different milestones in scale. AWS has nearly 2 times higher performance on SQL Server than anyone else, including Microsoft. One reason for this is that we have the fastest processors in the cloud and a robust network infrastructure. Our experience running Windows applications has earned our customers' trust. The number of AWS enterprises using Amazon EC2 for Windows Server has been growing more than 400% in the past 3 years. We have hundreds of thousands of customers bringing Windows to AWS, including Autodesk, which has been running Windows on AWS for over 10 years, and Salesforce, which has over 10,000 Windows instances on AWS. When evaluating a move to the cloud, cost is usually the conversation starter. We know that modernizing your workloads on AWS cloud is a journey, and cost savings is a big driver for this. TCO is table stakes, and customers have asked us for a better way to optimize TCO. For you to make your move to the cloud, we know that you have to start with looking at things like existing licensing, hardware and operational costs, and environments that are not optimized. This provides an opportunity to plan for efficient infrastructure and technology footprint. We also did a study that used the sampling of 100,000 servers running across various enterprises and found that when right-sized, we see an average savings of 36% reduction in infrastructure costs. This is largely due to the over-provisioning and underutilization of on-premises servers, so be sure that you look into right-sizing when you move to the cloud. The business value of running Windows workloads on AWS goes beyond costs of operating systems, databases, and infrastructure in the form of increased agility and operational performance. IDC did a recent study and talked to a number of our customers who run Windows workloads on AWS. This is publicly available, and I recommend you to have a read. IDC calculates that the organizations in the study will save 56% over 5 years in terms of cost of operations, which they can reinvest into innovation. They also project that these customers will realize an average 5-year ROI of 442% and have 98% in reduction in unplanned downtime. AWS has over a decade of unmatched experience helping thousands of organizations migrate and modernize their Windows workloads on AWS. AWS has translated this experience in our new Migration Acceleration Program for Windows, which is based on our proven MAP methodology of best practices that is recognized by IDC as the most extensive library of cases covering thousands of successful migrations. MAP for Windows also helps customers modernize their Windows, SQL Server, and .NET workloads on cloud-native, Linux, and open-source solutions. In addition, we are hard at work with our expert partners across the globe that you can confidently work with to help you with your Windows migration projects. Many of the partners we work with have hundreds of trained and certified AWS professionals spread throughout the world to help customers with their migrations in the locations they need help. In collaboration with our expert partners, we deliver partner-led programs for migration of workloads of any size and partner-led modernization programs for customers that are looking to leverage more cloud-native technologies to gain agility and remove license burdens. When it comes to modernization, many customers have had success in modernizing Windows workloads with AWS. But modernization involves more than merely moving workloads to the cloud. We are seeing an increasing number of customers moving from Windows and modernizing their applications on open source software to avoid vendor lock-in, take advantage of the innovations in new, more modern technologies, and just save costs. In fact, as per IDC data, Linux deployments will account for 77% of all worldwide server operating environments deployed in 2020 and are expected to increase to 82% by 2023. A great example of a customer that is successfully modernizing their Windows workloads with AWS is Visma. By running Windows workloads on AWS, Visma is giving developers the self-service capabilities they lacked in the company's previous environment. By migrating .NET applications to AWS and modernizing, they were able to go from releasing 6 software features per year to releasing 6 software features per month. By iterating faster on AWS, Visma can more quickly adapt to ensure they are delivering the best possible solutions for their customers. I hope this introduction has provided you an insight on how we are helping customers to migrate and modernize Windows workloads. Sergio Santos from Crayon is here to talk more about how partners are helping enterprises with their AWS journey. Crayon is an AWS Microsoft Competency Partner with a deep heritage in helping customers migrate and optimize IT spend. Crayon has over 100 AWS certified professionals across key regions in Europe, MEA, USA, and Asia. I now hand it over to Sergio. Thank you for joining us here today.
Thank you, Anthony, and thank you for your time today, for knowing better how is to partner with Crayon to start building on AWS Amazon Web Services. So Crayon's unique footprint within the cloud economic space is significant. Crayon is an advanced consulting partner that has already earned some competencies, including machine learning, IoT, and Microsoft workloads. Through this collaboration, Crayon aspires to become one of the world's leading Microsoft and AWS partners for migrations and modernization service. So let's see how is Crayon operationalizing the AWS adoption or migration to AWS. We progress along 4 core phases: readiness assessment, design, proof of concept, transformation, and also an ongoing one, grow and manage phase, where applies once we are already operating on AWS. So we recognize that all at once move to the cloud is usually not the best option. Our assessment services are specialized on designing and identifying, prioritizing which workloads to migrate and how to do that according to the best practice. We start with the readiness assessment over existing applications and supporting computing and networking infrastructure, producing a key TCO analysis, but not least assessing readiness from several perspectives addressed by the AWS Cloud Adoption Framework. So in terms of the tools we use for the readiness assessment and working as a team with you, we discover and analyze application portfolio and interdependencies. We specify actors and use cases as well. We map networking topologies, security technology, and processes implemented, and also evaluate licensing assets and agreements in place, compliance, governance, risks, and gaps for this transformation to the cloud. So, resuming here the common tools we use for those kind of analysis and what we address. We used to use TSO Logic for targeting right sizing and cost predictivity for on-premise based infrastructure. Also, Cloudomize when required to map complex environments with many dependencies for re-architecting scenarios when migrating from, for example, from infrastructure as a service to platform services. And we also are experienced on using Cloud Health when migrating from other hyperscalers already in the cloud, so we can start right-sized on AWS without migrating unused resources. Okay. In terms of the outcomes we used to get at this phase is the Cloud Adoption Readiness Report, Application and Infrastructure Assessment Report at the end, and some TCO analysis supporting the action plan we will propose you at after the next phase, the design phase. So here at this next design phase, we validate the foundational migration or modernization feasibility and capabilities available, the business case, and of course the plan for the transformation phase. And we at Crayon know how to start small and plan big. So we plan in detail for the existing workloads, the AWS service to implement, specifying foundation architecture components, identity, and workaround solutions designs that fulfill the valuable insights we've got from the previous readiness assessment phase regarding enhancements and remediation requirements for the applications. So for that, we bring to the project our specific subject matter experts as needed, according to the identified targets to focus on, as well as the AWS technical specialists, following the ongoing progress in order to ensure we are leveraging as many relevant and important AWS features as possible that can contribute to optimize continuously and at the same time reduce the usage cost and the burden of operations. So following the well-architected frameworks on design patterns and best practice for operational efficiency, security, reliability, performance, and cost control, we'll be able to achieve a sound solution and a feasible plan. So that plan comprises 3 parts. One, the specific proof of concept plan, preparing the next phase, that will address a real application in use that will be a good candidate for proofing the AWS service that will apply and that we are aiming to implement for that transformation. We propose you also a competencies plan specifying what technical competencies you should acquire, which roles should be developed and in what skills, what should be the roadmap for those competencies, who should apply for that, and how they can get trained and skilled. So if they will be more focused on hands-on experience, training lessons, or AWS accreditations, or even certifications. And of course, we present the consolidated transformation roadmap for the target workloads, including business case justification, supported by a concrete TCO analysis, and the timelines for each one of the transformation stages and their sequence. Third phase, the proof of concept, is also very important phase prior to start the migration, as we will validate the proposal roadmap with a real perception of the implementation effort and confirm key services or supporting tools to use, identifying in advance any constraint or relevant conditions to consider or applying them, such as volumes of data to be managed or migrating, business availability periods to preview and propose a migration plan, and also the licensing compliance applicable here, or any operational feasibility issue that we should consider as well. To a fair proof of concept, it's key to apply the same tools aimed to be used at the transformation stages over the most close to real scenarios as possible, even if we need to set up some automation for the producing the real environments. In case it cannot be used at the proof of concept, we can customize something and use some specific services in order to get it most close to the real environment as well. Therefore, your team will start an immersive experience on building on AWS, and we'll also explore the AWS management and governance tools. So at the end of this proof of concept, we will get, and this is very important, a clear vision on the transformation roadmap. Also an important tool here at this proof of concept phase will be our capability at Crayon to bring together with AWS some investments from programs available due to our recognized AWS competencies that may apply to your case. And then the transformation starts. Here we can have 2 different streams that can be combined, run along, or in sequence, depending on the specified strategy for each workload to address. And those main 2 different streams are migration and modernization. We establish a PMO for managing distinct projects or sprints, not forgetting the training and skills to be acquired and developed by the company's team according to the competence plan we have proposed before. So it's important to master well the cloud native services and all the aiding tools for building and operating on AWS. Here at Crayon, we are able and experienced on bringing in, as required, any specialized partner from our channel business ecosystem, if needed, in order to extend our delivery capabilities for addressing a mass migration, for example, or in the other hand, address a specific technology or framework applicable to a particular industry that needs to be implemented along with our transformation streams in progress. So for server-based workloads migration, and talking now about the tools, we are experienced on using Cloud Endure, or for higher transactional workloads, we use AWS Server Migration Service with many connector agents variants to apply depending on specific source environments at chance, as for example, the AWS SMS connector automation. For vendor license engines such as Oracle or Microsoft SQL Server databases to be replatformed to open source database engines, we use the AWS schema conversion tool for automating schema and code conversion tasks, using also the database migration assessment report output as a guideline for the transformation. Then for the data migration that will follow next, we can use AWS Data Migration Service or implement specific interim solutions with AWS services such as AWS Data Sync, for example, combined with Amazon S3 storage gateways. We used to leverage some specific AWS service also to manage migrations, such as the AWS Migration Hub, or other aiding tools for modernization stages, such as the AWS Cloud Development Kit, or many other AWS native services, such as those from the AWS Code Family, Code Build, Code Deploy, and so on, for implementing a CI/CD strategy for a continuous application build, integration, and deployment pipeline on the AWS cloud. So one of the reasons why we consider that customers need a partner is the capability and experience on the common challenges that customers face when aiming to build or migrate Microsoft workloads to AWS that I will address now along the next minutes. So we have several common changes here, like identity and access management and single sign-on integration to Active Directory services, re-architecting line of business applications. A good example is an ERP that we'll use, and also some other third-party ISV solutions, so other software vendors that build their own solutions on top of Microsoft technology. We used to address also the platform of SQL Server databases to RDS SQL Server, or apply, in some cases, the database freedom practice to migrate SQL Server to RDS Amazon Aurora, or scale Windows file servers to manage Amazon FSx for Windows Server, produce a virtual catalog of Windows client applications with Upstream, for example, or manage virtual Windows desktop fleets with Amazon Workspaces, rehost enterprise apps as the customers are running on-premise, like SharePoint servers or Exchanges servers, and modernizes .NET applications and work around the licensing optimization and compliancy. With both options, bringing your own license or buying directly from AWS. So one important topic here is the identity and the access management when planning to build and operate on AWS, following the best security by design best practice, and where we leverage also many services or features for providing end user a seamless experience when consuming service, running, and being managed on AWS. It specified what kind of directory services we will set up, what topology, how we will integrate with existing environments, what restricted user information should be accessed, what kind of authentication and single sign-on mechanisms and means we should implement, and what policies to establish and apply. We also established the target AWS account structure, as well as the landing zone features and controls required or useful for your company's operation. So now let me use this blueprint architecture to exemplify some of these common challenges, and I will go through in a bit detail, just for having for you to have an idea what are the typical scenarios and how we start building and complementing along with many AWS services. So, and the best thing for me to work more and more from project to project with AWS is that I can really architect like a dreamer and build like a pro. Yes, really. So we feel that when architecting or building together with AWS and the customers along our experience, setting up brand new workloads or migrating for modernization, we really apply by design and seriously the 5 pillars principles on everything we do around security, reliability, performance, operational efficiency, and cost control. So I'll show you how we leverage AWS service around optimizing value continuously based on those well-architected pillars. So let me start with this blueprint architecture and show you what kind of common Microsoft workloads we use to address and are represented here. So here and at the left side, you can see a customer premises for this particular use case. That is a non-premises data center, but it could be also a Microsoft Azure subscription or any other cloud provider's premises. Okay, so here is at the center, and if you can see my mouse now, a typical virtual machine running in the cloud. So we have here an ERP solution provided by a third-party software vendor that develops on top of Microsoft technology. So this is an application server developed on top of Microsoft.NET framework. This virtual machine also includes an IIS internet web server for supporting the web application for the end users and business partners represented here on the top outside of the organizations for placing orders or delivery tracking, for example. And both applications, the ERP application server and the web server, are based and supported at the backend by a SQL Server database. And typically, all of these 3 components, application server, web server, and database, are installed in a single Windows server virtual machine. So when hosting that virtual machine in the cloud, the most common deployments we unfortunately see quite often is to place it in a public accessible subnet with basic protection, compromising security, reliability, and also cost effectiveness, because that virtual machine needs to be sized for the maximum requirements for the database, which requirements are much more demanding than if just for the application server or web server. So our first enhancements when addressing a scenario like this is to start decoupling services from that single ERP solution hosted in a single virtual machine, and decoupling it and re-architecting for those components for better security, reliability, and availability, and right-size computing resources according to each service individual requirements. And we used to do it this way. So we bring the server instance that typically is posted to the public internet, and we bring it to a private subnet at the backend. Then we deploy the web service across multi-availability zones. So we choose 2 different availability zones and implement here the auto-scaling group to leverage the scalability that AWS can offer for you. And so the web server tier we decouple from that instance and set up an auto-scaling group with a minimum of 2 instances, 1 at each availability zone, reached from the internet through an application load balancer where web application users can connect to it after being allowed through the set of AWS traffic and security management services, such as the Amazon Route 53, AWS Web Application Firewall, and Internet Gateway. So also complemented and not represented here by easiness of reading, but we We also set a security groups strategy in place for ensuring least authorized service possible. So the next step is to get the other component and decouple from the EC2 instance and bringing to an RDS SQL Server instance. So in order to keep the same engine for ensuring that the software vendor will maintain the support and avoid any compatibility issue with the application, we decided to keep the same engine, so with SQL Server, but hosting and migrating the data to another SQL Server, but now running on Amazon RDS. So options here are to create another availability zone, a second synchronous failover instance for high availability, or at least an asynchronous read replica that can be used for offloading from the master instance and any data consumers, such as reporting services, many of them running from the customer premises or from other web service. So, and here is represented that second option, the asynchronous read replica, but running on another availability zone and offloading the load from the master database for reporting purpose. So this way we will have more smaller and scalable components and a well-defined and strict service authorization between networking layers and access requirements. So we have transformed also a significant single unit of cost that at the first was based in a single virtual machine with many resources because of the databases. And we have transformed that single unit of cost into a more flexible cost structure that will allow us to enforce or easy it as required along the time. So if we need to enforce more or to provide more resources to the web application tier or to the application service tier or to the database, we can do it independently and be able to scale as needed. Another important thing is when we get to plan to the VPC structures, that are some important insights from the readiness assessment phase. We consider here the actors and the use cases we have assessed. So in this example, the ERP is supposed to be assessed by internal users through the ERP client application, typically installed at the user Windows desktops. So we have here the typical users, and from their end desktops, they run their at the Windows desktops the client application to access the ERP. Their authentication should be a single sign-on on the corporate Microsoft Active Directory. Here at the bottom, that is still at customer premise because of some dependencies to be addressed at the further stage. Besides that, customers want to extend their file services based on Windows Server mounted drives with a more reliable solution. So we consider to use Amazon FSx for Windows Server to be a good service to complement and to extend their needs to the cloud. That said, it makes sense to create a VPC dedicated to corporate services, to where we will establish a single sign-on and a data sync from the customer premises to the AWS dedicated VPC. So this one represents us that corporate service VPC, independent from the VPC dedicated to the ERP. Okay. So a customer has got a set of users also most of the time out of the office, just requiring the Windows desktop for 1 hour a day. So a virtual desktop with a standardized and approved Windows 10 image with company's application catalog deployed and so on will be the perfect solution. And if we build that with the Amazon workspace, we will have a much more cost-effective solution than buying desktop operating system, licensing and core calls, and so on related to that for being used just 1 hour per day. So that specific ERP client application used by the users can be also installed at the Amazon workspaces for those sporadic users, but also in Amazon upstream, the other service for some users that are out of the office, represented here on top, that works for longer, but those users, a common case here is the users from a BPO partner to where you outsource your back office tasks, such as contract management, payments, and debt collections, for example. So those BPO users in charge of managing contracts and payments also will need to reach your ERP and run the ERP client application. So upstream is a good AWS service to fit the needs here. So in that case, they can access directly the upstream service for running strictly the ERP client application in that case. And you can limit also that restricted access to the restricted application for that task. So you don't need to expose access to your customer premises or access directly to your ERP. So you have restricted access to a single application that they need to do their tasks. Okay. There will be some other BPO users, for example, in charge of doing collections that will need also to use old Windows client applications based on Microsoft MFC or Java Swings for Windows in order to interact with those HP, UX, Big Voice still hosted at the customer premises data center, usually hosted on-prem. So instead of deploying MPLS VPN connection to the BPO partner location between your customer premises and the BPO partner premises, we deploy these upstream services for installing there an image with those messy applications that are based on Microsoft Windows Client registered DLLs or based on those traveling Java runtime environments versions that were developed some years ago and are no longer supported, for example. That way, your business process outsourcing users can use only the restricted applications, even when from during pandemic crisis, for example. Otherwise, it would require that those users should be allowed to access to the BPO partner location to access the VPN to your customer premises. Okay. So, as you may have already been noticed that this architecture blueprint, the interconnection between the ERP VPC and the VPC, including the corporate services, and also integrate via site-to-site VPN to the customer gateway at the customer premises, are managed by a centralized service that is Transit Gateway here at the center. So here we have attached the site-to-site VPN, and we will be able to scale and bring more services to AWS in being prepared for the future to provide more dedicated VPCs to specific workloads or specific needs, and we can manage along and be able to scale this architecture. So, going now specifically about modernizing .NET applications. So you can get more and better from your existing ones. So when it gets to modernizing, .NET applications that you're moving to AWS or building new ones there, many options will apply. You can build modern applications for .NET Core and PowerShell, or automate and run pre-configured .NET Core environments for faster and better performance when comparing to Microsoft .NET Framework. So you will not only leverage your already existing knowledge and expertise on developing and maintaining software, but we will also benefit from a boost on your application's performance that .NET Core will bring to them. We can also implement a continuous integration deployment strategy with Amazon Code Family Services and Cloud Development Kit for integrating with Visual Studio, for example. So it's important that you can keep your developers' common IDE environments as is, or if you prefer, you can keep using the same tools for pipeline management. It's up to your developers team. So we can also leverage Amazon ECS Windows support and Windows image on EKS for redeploying containerized applications. This means in case you are already deploying applications upon containers, for example, or more specifically in Kubernetes on top of Windows images, you can bring them to AWS, but we can also leverage your AWS managed services available to you for managing not only the setup, but more important, maintenance and change the management of your application deployments and common parameters at your containerized architecture with some Amazon ECS or EKS native and integrated enhanced features that otherwise would require you to configure each YAML file at a time, for example, incurring you in possible failures, or adopt other third-party tools to learn and master in order to manage securely those changes. So an important value we see here is to adopt those possibilities that the Amazon included managed service for ECS and EKS can provide to you. Okay. Around containers, another significant improvement more related to cost savings we can bring here is to set up smart mechanisms of combining EC2 autoscaling group setup with spot instance, for example. Many of the supporting EC2 pools for the autoscaling groups can be based on spot instance for ensuring your computing capacity will be supporting your containerized architecture is running in a cost-effective manner at every single moment. Okay, and at the end, you're at the bottom. So as I'm saying, you can leverage your .NET programming skills with Lambda functions to redeploy or your code, or start building many reliable, scalable, and secure true serverless applications, not concerning to provisioning or procuring infrastructure or building or setting up infrastructure. You just be concerned to the application issue, and you will pay only for the transaction and not for the infrastructure underneath. Okay. Regarding now about licensing optimization and compliance. So you can bring your own Microsoft licenses or usage rights to apply them to AWS, or you can buy licenses from AWS as long as you use them. So if you plan to bring your license to AWS, there are many options to evaluate regarding the suitable EC2 tenancy to go for, and plan around reliability, high availability, and right sizing trade-offs you need to balance in order to be cost effective. So we can also implement AWS License Manager for managing well your license assets. And on the other end, if you don't want to concern much on that, and if you prefer to release some of your licensing ownership and consider to buy licenses from AWS, we will work on a well licensing plan for keeping you compliant when you're migrating as is your Windows servers or SQL servers to Amazon EC2. because there are specific pre-tasks and post-tasks to be prepared and executed even when migrating in a lift and shift motion your existing Windows servers to EC2 target instances using Cloud Endure or Server Migration Service, the AWS SMS. So we need to be aware along that migration process that we will keep you compliant with the licensing rules. Another important topic is the end of support migration. So when we are migrating servers, Windows servers 2008 or older versions that are already at the end of support, and with that compromising your security and compliance for your business, or bringing you and burden you with some added operational cost. There are some tooling that we call the AMP for that make it possible to create a compatibility package to be deployed on top of a target instance. So we will have at the end not an EC2 instance with a version of operating system that is no longer supported, but we will create a new one with a new and supported Windows Server version, and on top of that we will deploy a compatibility package with that will support your legacy application without the need to change a single line of code or upgrade any of their legacy dependencies, like older .NET frameworks dependencies, DLLs, whatever. So here is where we see that it's always important to be continuously supported by a Crayon that knows well the licensing options that apply to the specific customer scenario at every single moment, because Microsoft changes them quite often. And the software assurance rights are decreasing and getting deprecated fast, becoming every day more and more restricted to customers still using virtual machines, even for their own cloud customers. So it doesn't work to keep locked to it, and it's a good motivation for start looking for other no license dependency options, like open source supporting operating systems or open source database engines, in which AWS invests and innovates a lot on alternatives every day, not just for affording you performance, reliability, and security, but also for offering you the true serverless paradigm in order for you to pay only for the transaction by the millisecond activity. It means zero when idle, and managing well with near zero cost your own data. So finishing now, you can Google Crayon AWS Partner, so you can check for more about Crayon at our crayon.com website, or check our partner profile details at the Amazon Web Service APN portal. But I can briefly present you Crayon. So here at a glance, Crayon is a Nordics-based company, but covering more than 80% of the addressable market globally, with 45 offices worldwide in over 30 countries. So we are around 1,500 people now. Most of us technical experts, consultants, prepared to help clients navigate complex and business critical technologies through our unique talents, tools, and systems to optimize the returning of investments on their technology investments. So optimize and transform continuously is at our DNA. So that's what the real, and that's why it makes sense to develop our partnership with AWS and together with you to leverage all the best AWS technology can provide. So I just want to thank you for your time, and I hope I helped you to get more clarified and confident to start migrating your Microsoft workloads based on AWS and how to enhance them once there and become a cloud native builder, and what our capabilities are for partnering with you along that journey.
Thank you, Sergio. Thank you, everybody, for joining. We hope you have a nice day.